My name is Art, and I worked in the uranium area here in the Grants area from 1957 until 1994. I'm going to talk to you today about the underground station area where you are located at this time. This is the area at the shaft where all material that comes underground is handled, such as timber, wire rope for slushers, explosives, and many other supplies. The employees also were conveyed to this location down the shaft in the cage in which you just stepped out of. Ore and waste was hoisted to the surface by means of special equipment called skips. These skips were usually counterbalanced. As the loaded skip was hoisted to the surface, the empty one was going down and its weight helped to pull the loaded one to the surface. Please direct your attention to the items that are being illuminated. The small winch is called a tugger and was used to pull or remove material from the shaft conveyance called a cage. The ore car sitting here is classified as a 77 cubic foot car and would hold around 4 tons of ore. Over in the far corner is located a porta potty. These were strategically located in the active areas of the mine and generally were serviced on graveyard shifts. In the immediate area of the station were located the settling basins and pump rooms for gathering and pumping the water that flowed into the mine and directed this water to the surface. Notice the metal drainage ditch in the middle of the drift. The ditch transported the water to the pumping facilities. Explosive magazines, supply storage, shops, and lunchrooms were also located nearby.
My name is Hal, and I worked in the uranium industry 30 years. Distribution of all material in the mine was achieved by the use of locomotives and trains. The locomotive in front of you is a 4-ton battery-powered locomotive that was capable of moving 5 or more ore cars from the production areas to the shaft. It was also used for transporting ground support material such as timbers, rock bolts, wire mesh, as well as explosives. Miners working long distances from the shaft were transported in specially built cars to and from their working places. It should be noted that the mines were also equipped with 8-ton diesel locomotives, as well as rubber-tired loaders, trucks, and other trackless mining equipment.
Hello, I'm Jack. I have 28 years experience in the uranium mining industry at Ambrosia Lake. The steel chute being illuminated were used by the motormen to load the ore into the cars for transportation to the main shaft. The control valve on the opposite rib was used to open and close the door of the chute until the ore car was loaded to the motorman's satisfaction. As the ore horizon was generally above the haulage level, the miner used gravity feed to assist him in loading the ore into the ore car.
My name is David W. Ogden, Jr. I began working in the uranium mining industry in 1956 as a driller's helper, later worked as mill laborer, open pit and underground miner, underground mining supervisor, and finally chemical mining and surface reclamation. From the mine's stations or mining levels, haulage tunnels or drifts were advanced by drilling and blasting. The broken material was then removed by a mucking machine shown here. The miner would stand on the steel plate step, and by moving the handles on the side of the machine, he would cause it to advance into the broken rock and then lift the bucket over the top of the machine and deposit the material into the ore car behind it. This would clean out the track drift face in preparation for another cycle of drilling and blasting. Please note the service lines overhead. The 4-inch pipe was used for distribution of compressed air. The 2-inch steel pipe was used to bring water into the mine for use in the drilling operations. There was also a red electrical line, which was used to carry the electrical current to the loaded blast holes. The black electrical cable provided electric power to the fans, slushers, lighting, and other electrical equipment. Also, please note the ground support provided by the bolts, square washers, and the chain link fencing evident in the area of the haulage drift. This combination of bolts and chain link fencing was used to stabilize the ground and reduce the chance of rock slabs falling and injuring personnel and/or equipment. The bolts in the sides or ribs were 4 feet long with an expansion anchor or shell on the end of the bolt. They were torqued to a minimum of 140 foot-pounds. The bolts in the back were 6 feet long, and these were torqued to 180 foot-pounds. A raise is a hole driven vertically to gain access to the ore horizon. The raise you see here is a manway with ladders and a service compartment beside it, which was used for hoisting equipment such as slushers, slusher buckets, ground support materials, and explosives to the ore horizon. Some raises were driven for ventilation purposes, either for moving fresh air to working places or removing contaminated air to ventilation holes to be exhausted from the mine. Ventilation shafts or vent holes were used for exhaust or intake of atmospheric air, depending on the particular mine's ventilation requirements or plans. They were drilled from the surface with a drill rig and cased with steel to prevent caving. The diameter of the hole was engineered to transfer the optimum amount of air for a particular mine area and was typically at least 4 feet in diameter. Thousands of cubic feet of air per minute were transferred by a network of ventilation holes. As you leave this station, you will be leaving the haulage area and entering an area of the mine that represents the elevation where the ore is located.
My name is Ernie Lucero, and I've had 30 years in mining experience. The ore was blocked out into pillars in preparation for the final step in this type of mining. The pillars are then drilled with a series of holes, which are then loaded with explosives and blasted. The broken ore was then moved to an ore pass with a 3-drum electric winch called a slusher and a bucket. The removal of these pillars created a large opening that was called an open stope, or a ballroom similar to the one you see here, only larger. Some mines backfilled these stopes with sand after the pillars were removed to prevent large-scale caving. No one was allowed in these open stopes at any time, or they would be automatically terminated.
My name is George, and I've worked in the mining industry for 44 years, 26 years underground for Kermagee, and 18 years in surface coal mining for the Lee Ranch mine. The machine you see here is a jack ray, rig driven by hammering and rotating the bit. It is fired by compressed air and uses water to wash the cuttings away from the bit. The water passes through the stem of the drill steel to the bit. This type of drill was used to drill blast holes for various phases of the mining process. The telescopic leg attached to the drill assisted the miner by forcing the drill steel into the hole as it was advanced. By adjusting the flow of the air to the leg, the castings portion was applied to the drill bit. The average grade in the rock you're looking at is about 20%. Please note the rope jack located near the machine. It must be placed within 6 feet from the driller. This was for the safety of the miner, as vibration from the drilling operation would sometimes dislodge slabs of rock that could seriously injure him or her.
My name is Tom Inyo. I work in the uranium mining industry for 29 years. Most of these years were put in at Church Rock mine site near Gallup, New Mexico. Vent drifts were driven to provide a means of discharging contaminated air from the active working places, or to provide fresh air to a particular part of the mine or working places.
My name is Bill. I've spent all my working life, all in uranium, mostly here in the Grants area. You're now at Station 8. The holes you see here were drilled with a jack blade drill, one of which you saw at Station 6. Then the holes are loaded with explosives and primed with electric blasting caps. Typically, the caps were placed inside a stick of dynamite, which was shoved to the end of the hole with this wooden stick you see in the corner. And the rest of the hole was filled with ammonium nitrate. The blasting caps were timed to explode in a certain sequence, causing the drift or tunnel to be advanced to the depth of the drilled holes, usually about 6 feet. Please note the middle hole at the top of the drift is drilled about 2 feet deeper to be used as a pinhole. This was so the miner would have 2 feet of hole to insert a short rock bolt and a cable pulley to remove the ore from the blasted face using the slusher you will see at the next station. The long hole drill in the drift opposite the loaded round is an air-driven rotary extension drill machine and was capable of drilling 300 feet or more into the rock overhead. The primary purpose of this drill was to delineate the overhead ore body. After a series of fan holes, a Geiger counter was inserted to the full extent of the hole, and the grade or concentration of the uranium was logged on a chart. This information was plotted on a map by geologists, who then calculated the available pounds of uranium in this particular ore body. Notice the safety jack located behind the machine. The long holes drilled by this machine also drain water from the rock overhead, improving the ability to recover the ore and create a much safer working environment. Normally, the host rock in which uranium was deposited was generally very wet, causing the rock or ground to be unstable and unreliable.
My name is Ray, and I've been working in the uranium mining industry for 30 years. Remember the subdrift round with the loaded holes? The face you see here with a scraper in it is the result of the blasting of the 6-foot round observed at the previous station. Note the shear block hanging from the rock bolt in the back of the new face. The drifts we have observed so far were driven in the ore body to block out the ore into pillars, which averaged about 35 feet square. The drifts were created by drilling and blasting as seen earlier. The drifts were knocked out with the 2-drum slushers seen here and the scraper that you see in the end of the drift. The broken material was pulled into the race using the scraper where it was dropped down and stopped by the gate on the steel chute you saw in the haulage drift. A grizzly made from old rails is placed at the top of the race. The spacing of the rails was 14 inches to prevent a miner from falling into the race and to limit the size of boulders in the chute or ore pass.
How would you like to work in something this enclosed? Jeez.
It is pretty tight.
My name is Van. I've been working in and around the mining industry here in the Grants area since 1960. I would like to tell you a little bit about what you're going to see here in the shop. In order to keep from having to hoist the equipment to the surface for repair, underground mechanic shops were established for the purpose of performing major repair to the mining machinery. If there were more than one production level in the mine, there was usually a repair shop on each of the levels. Some of the equipment repaired in these shops were slushers, slusher buckets, drill machines, mucking machines, locomotives, and ore cars. Just about anything imaginable was performed by these talented underground mechanics. Please note that the shop has been stabilized by the use of rock bolts and wire mesh to control the ground. There was also an electric shop underground similar to this mechanical shop, where repairs were made to the electrical components.